Alright, welcome back to Mr. B's math class. Today we're looking at 2.1, add and subtract decimal numbers. So today our student outcomes are I can use estimation to check if solutions are reasonable. So we're looking at estimating today. And number 2, I can solve problems using addition and subtraction of 2 or more decimal numbers. What that means is the main focus of today's lesson is going to be estimating decimal numbers and then doing the actual calculations of adding and subtracting decimal numbers. A few key terms for today. Number 1, estimate. So what an estimate is just to approximate an answer. Try to find what it's closest to what it might be. Overestimate or overestimate, it means that you're estimating larger than what the actual answer would be. And underestimate is estimating the smaller than the actual number would be. So let's look at now a couple examples. So let's look at example 1. So it says use estimation to place the decimal point in the correct spot. So what that means is we've got a few numbers here that we're adding together and we've got an answer, but we don't know where the decimal is going to be. So we're going to try to estimate to figure out when we add these three together, where will the decimal fall? Will it fall here, there, there? Who knows? So let's try method 1 first. So method 1 says front end estimation. So the first step to this, it says, is keep the first digit the same and the rest becomes 0. So what we're saying is, before we even try to add anything, we're going to look. Our first number here, we're going to look at the first digit, which is 8. It says keep it the same, and the rest becomes 0. So, in following with that, that means that we're going to have 8, and then the rest becomes 0. It would be 80. We can ignore the decimal point there. 80, if we wanted to, we could do that, but it's not really important because we're working at just what's in front of the decimal. So it becomes 80. Plus, when we look at the next one, the first digit is 1, so it stays the same, and then the rest becomes zeros, so there's just one number after, so it becomes 10. We're going to ignore these. The next one we have is 73, so it's 7. We keep it the same, and then the next one becomes 0, and we can ignore those because they're on the other side. Now, step 2 says do the math. So when we look at what we've got here, we've got 80 plus 10 is 90 plus 70 becomes 160. And the decimal always falls at the end of our number. So we know that the answer, the decimal, is after the third digit. So when we look up here, we've got 1, 2, 3, and the decimal would fall right there. So our answer in reality would be 175 decimal 970. So we've estimated it accurately here. Let's look at the next method. So method 2 says relative size estimation. So I know there's a bit of writing on here, but I want to do it ahead of time for you so we could explain it and go through it. So relative size estimation is actually really easy. All you're doing is using the rounding rules. So the idea that is it closer to this or is it closer to that? So the idea of what relative size estimation just really is, if we had the number 27, is it closer to 20 or 30? Well, we know just looking at it that 27 is closer to 30. So we just round that to 30. 174, is it closer to 100 or 200? Well, it's closer to 200. 2,261, is it closer to 2,000 or 3,000? Well, we know that it's closer to 2,000. That is all that relative size estimation is. That is it. It's just taking that number off the bat and rounding it to whoever's closest. Unlike the last one where we were trying to replace zeros and everything else. So if we take this idea here and we apply it to the question from the last page, we're going to do it like this. It says use the rounding rules. So we have 87.85. We know that this number falls between 80 and 90. When we look at it, we know that it is closest to 90. So we round it up there. Plus, we look at 14.60. We know that that number is between 10 and 20. When we look at it, it's just barely closer, but it is closer to 10. When we look at 73, we're looking to see if it's between 70 and 80, and it is closer to 70 than it is 80, so we keep it as 70. So when we add these together for step 2 here, it just says do the math. So 90 plus 10 is 100, plus 70 becomes 170. We've estimated again. Remember, we're not looking for the exact answer, we're just estimating. So now we got 170, and we look back again, that'd be the third decimal spot, which would have got us the same answer. So again, it's pretty easy, right? We're just to review this again, you're just taking whatever the numbers they have, and then just rounding it to whatever the nearest number would be, right? And that's it. So let's go to the next example. So example 2, we've got a bit more here. We have got 485.20 plus 38.73 plus 20 plus 785.10 equals, and we've got our 6 numbers there. I again want to know where is that decimal going to fall in that number. So I would like you to try using front end estimation here and relative size. So go ahead, you can pause this video, try it yourself, and then hit play when you're finished to see how your answer matches up, and then you can adjust if you need to. Okay, so if we are doing our front end estimation here, we are just going to, like we know from before, take the first digit and then make the rest 0. So in our first number here, we had 485. We keep the 4, and the rest becomes 0. Plus 38.73, we keep the first digit 3, the rest becomes 0. We ignore that backside decimals. Plus 20, well, the first digit stays the same, rest becomes 0. That was pretty easy because it stays the same. And 785, we keep the first digit and the rest becomes 0, which when we add them all together gives us 1,150. So we know right away that there's the 4 decimal spots here, right? We have our 1, 2, 3, 4, which means that our decimal on here is going to end up after the 9. So pretty easy there. Let's look at relative size. So once again, when we're looking at these numbers up top, we're going to look at 485 first. So when we look at that, 485 probably falls between, as we know, 400 and 500. So that is definitely closer to 500, so we're going to put 500 there. When we look at 38.5, it falls between 30 and 40. When we look at it, it's obviously closer to 40, so we'll keep the 40 there. 20 isn't between anything because it'd be between 20 and 30, but we know that it's bang on, so we're going to keep it the exact same. And 785 we know is between 700 and 800. When we look at it, it is closer to 800, so we add 800, which gives us a grand total of 1,360. So once again, that's our estimate for what we think this would be. We know that it's got 1, 2, 3, 4 decimal spots, so again, 1, 2, 3, 4, and it still falls in that 4th spot. So both of these are pretty easy. The text might ask you to do one or the other, but if it gives you the option, pick the method that works best for you. So let's try one last example. So here we have a subtraction example. We have 4,189.675 subtract 1,501.94. Again, we want to know where that decimal falls. So let's take a look at this. For front end estimation, we have the same idea. That 4 stays the same, the rest becomes zeros. Subtract, we have 1,501, that 1 stays the same, the rest becomes zeros. So our estimate is just 3,000. When we look at our number up here, that's 4, this is 1, 2, 3, 4 decimal spots, 1, 2, 3, 4. We know that the decimal is going to go right there. If we were to use relative size, same idea. We're going to look at the idea that 4,189 is between 4,000 and 5,000. It's closer to 4,000, so we're going to keep it the same. And when we look at 1,501, we know that is between 1,000 and 2,000. Now just barely, but because it's 1,501, that 500 will round up to the 2,000, so it rounds up to 2,000, which gives us, oops, I just realized my mistake. I am not adding here, I am subtracting. There we go. 4,000 minus 2,000 is 2,000, is our estimate here as well. And when we go again, that's 1, 2, 3, 4 decimal spots, which keeps it the exact same there in that fourth spot. So that's it for estimation. Now let's take a look at some actual addition and subtraction. So our first example is adding 13.4 and 7.1. So it says step 1, line up the decimals, which is the place values lined up properly. So if we were to do this, we would take 13.4 and we would line up then 7.1 so that when we look at it, our decimals here are in a straight line. They're not moved around. It's very easy. So once that is done, step 2 just says do the math. So I have 13.4 plus 7.1. 4 plus 1 is 5. We have to make sure we take our decimal down, keep it the same there. 3 plus 7 is 10, so we add a 0 and then add a 1 up top. And 1 plus 1 is 2, so it becomes 20.5. And that's kind of all there is to adding and subtracting. So let's try another example. So example 2 here says 7.8 now subtract 3.2. So if we're following along with our rules, step 1, if we remember, said to line things up in the place value. So 7.8 subtract 3.2. And then step 2 just said do the math. So 8 minus 2 is 6. We take that decimal and keep it down. And 7 minus 3 is 4. There's your answer, and that's all there is to this. So let's try one last example that you guys can do on your own, and then we'll be done. So example 3, we have 14.620 added 5.019. So I'd like you to pause it, do it yourself, and then hit play to check your answer. Okay, now that you've done this here, let's try this out. So step 1 again always says line up your decimal points. So we have 14.620 and we're adding 5, there's the decimal together, 0.019. Step 2 just said do the math, so let's do it. 0 plus 9 is 9. 2 plus 1 is 3. 6 plus 0 is still 6. Our decimals come down. 4 plus 5 is 9, and 1 plus nothing is still 1. And we have our final answer of 19.639. So that's all there is to this. I know this is a little bit of a longer lesson than usual. We had a few things to cover. If you're a little bit confused, that's okay. That's what tomorrow's for. So feel free to come tomorrow to class and ask any questions you might have. Other than that, we're all done for today.